All right, so as you can see from the title slide, I'm going to be talking about file formats. So let's first deal with what is a file. So I am not talking about those things that you use in woodworking or on your nails. I'm talking about as it relates to computers. So files are those things we see that store our electronic and digital data. So that may be our pictures, it may be our Word documents, it may be anything else that we're creating on the computer. So it's our electronic and digital storage of data. Well, as the first slide showed, I'm going to be talking about file formats. So what do I mean by the format? Well, if a file is the electronic digital storage of data, the format determines the way the format and the content that is being stored. So if we are taking a picture with our digital camera, then the data from that picture has to be stored in a certain way. If we are creating a Microsoft Word document, the data related to that document has to be stored in a particular way or format. There has to be some agreed upon way. Well, there are many different types of file formats. Because this is for a multimedia class, what are some of the multimedia related formats? So multimedia related file formats. So really what we're trying to talk about here is what kinds of data, what types of data do we need to store? Well, typically it is for video files or audio files or graphic types of files, animations, web pages, and so on and so forth. So we're talking about the types of files and the type of file formats used for these different kinds of situations, these different kinds of multimedia. Well, what I'm going to focus on primarily is going to be the graphic file formats. Now, many of the concepts I'm going to be talking about in relationship to that will still apply to some of these other kinds of multimedia elements. For example, in graphic file formats, we're going to be talking about compression. That still is going to relate to video and audio files, and in some cases some of these other kinds. We're going to be talking about bit depth. That can also apply to some of these other ones. But my focus is going to be on the graphic file formats. One other thing before we get going here. Let's also deal with some different types of file formats. And let me explain what I mean by that. What I'm referring to here in this particular case is that in some applications, that application will store the data in a particular format that is unique to that application. I'm referring to those then as native file formats. In many cases, those are proprietary, meaning that that is a, I want to say, company held secret, but it's specific to that company and to that application. And in some cases, other companies, unless they're willing to pay, cannot use that file format. For example, when you create a document in Microsoft Word, they are oftentimes saved as .docs or .docx. Those are the native file formats for Microsoft Word. Now, that doesn't mean other applications can't save in those file formats, but the .doc and .docx are native to Microsoft Word. If we were to save a file in Photoshop, the native format is the .psd. Again, that doesn't mean that Photoshop can't save in other formats. It doesn't mean that other programs can't save files as PSDs. What it means simply is that Photoshop, its native format is the PSD. Another example, Adobe Acrobat. Its native file format is the PDF. So that's what I mean by native. Now there are many file formats that are not native formats, meaning that they're not unique to a particular application. They are shared amongst many. They were developed not as a result of a particular application, but for a particular use. And we're going to get into a number of those because those quite often are the graphic file formats. For example, and I don't have a real good name for these, I'm simply going to call them the non-native file formats. These would be things like the JPEG, like the GIF, like the bitmap, and so on and so forth. Many applications will be able to save in those formats, but again, they are not specific to an application like the other ones are when I'm talking about native. All right, so let's take a look here at another topic here. We can, when we're looking at graphic file formats, so as I mentioned, I'm going to be focusing primarily on these graphical or graphic, let's go with graphic file formats. So we're looking at file formats that are going to be used to store graphical types of information. And as it relates to multimedia, that might be pictures from a digital camera, that might be something that we've created in Adobe Illustrator, that might be something that came from a scanner. It can come from a number of different sources. In looking at that, we can take and classify these file formats in one of two categories. Those would be the bitmapped file formats and the vector file formats. Bitmaps sometimes will also be called raster or rasterized formats. In a bitmapped image, bitmapped file format, the image consists of a series of dots, pixels. So the file format for a bitmap type of image has to be able to store the data, which is typically color information, for each one of those pixels. For example, let me just briefly switch here to a different application. Here I have a photograph, and this photograph, if I were to magnify it and magnify it to a very high level, you'll see these little boxes. These represent each one of the pixels that are in this image. that bitmapped file format has to be able to store the color information for each one of these pixels. In this particular case, we can actually take a look. Just 1 second. And see that there are 2,592 pixels across, and the image is 1,944 pixels tall. So if we were to multiply those two together, we'd have the total number of pixels that are in this image, and a bitmapped file format would have to store the data associated with each one of those pixels. As you can see with a bitmapped image, as I zoomed in, the image became what we call pixelated. It became having these edges, and it lost its clarity and its detail. That's because there is a limit to the amount of detail in that image. It is a result of the way the image is created. It's as though we have painted by numbers, and we have colored each of these little squares a particular color. Now, if we get those squares small enough, or we get far enough away from the image, it looks very good. But when we zoom in, we can get that pixelation. The other type I mentioned is the vector-based file formats. These are file formats. These are images that are typically areas of solid color, lines, shapes, typically not photographic type images like the bitmapped images, and therefore the image is represented by a series of draw instructions. In that manner, then as we resize the image, the elements in that image are constantly redrawn. So it never becomes pixelated. For example, again, you just give me a second while I switch to the application. Here is Adobe Illustrator. Adobe Illustrator, I've created a very basic and simple line. If I zoom in on that line remains sharp even though I am at 64 times the original magnification. Had this been a bitmapped image of a line, we would have seen this made up of those square blocks. It would have been pixelated. This is a very simple example. If I switch it to a different type of image, one that has more elements to it, first of all, you'll see that this being a vector type image, it is primarily made up of shapes, and those shapes contain areas of relatively large amounts of color. So we're not typically looking at vector-based images representing photographic images. Once again, if I zoom in on this, because even the text is vector-based, it will not become pixelated. So I am again at the maximum zoom here in Illustrator, and you'll see that the curved portions of my text still remain sharp, because as I'm zooming in, it's constantly redrawing these elements in order to maintain that integrity, that quality of that image. So let me go ahead and switch back. Okay, let me go ahead and erase this. So just give me a second. Okay. And this is going to be primarily for the bitmapped file formats, we can look at compression. Graphic images usually again because we're talking about bitmapped images, and usually with bitmapped images we're often dealing with photographs. These files can get quite large. We have a huge number of pixels and lots of information about those pixels in order to record. And that takes up a good deal of space. So in order to make files smaller, we use compression. So there are two types of compression that can be used. There is lossless compression and lossy compression. With lossless compression, we are keeping all of the data. We are not throwing anything away. The amount the file will be compressed, the amount that the file size will get smaller, is not going to be enormous. It will get smaller, but not by as much as the lossy file formats. And here's why. We're not throwing anything away. We still have to keep all the data. So there's not as much room to compress it. You can think of it this way. If the file is a suitcase, the format determines what's going to go in the suitcase and how it's arranged. In a lossless file format, we want to keep all of the items, but we've got to make them fit in the suitcase, and we want it to take up less space. So we can come up with a way to organize the contents of that suitcase in a way that it takes up less space. Maybe, for example, we've got an item in our suitcase, like maybe a makeup bag. Maybe we can put something else in that makeup bag that we wouldn't normally have placed in there. So rather than having that makeup bag take up space and in that makeup bag there be an empty space, we're not going to make use of it. Well, with compression, one way they'll do that, it'll take a look at an image and see that maybe there's large areas of relatively the same color. And so they can describe those pixels in such a way that it takes up less space. Now with a lossy file format, the file is made smaller, and it's made smaller by throwing away data. That is the primary way that it does it. So it is going to get rid of some of that information about that image. Some of the file formats, the lossy file formats, are very good at throwing away things we won't notice. And so we can compress the image a good bit and not really notice any significant change in that image. Now, the more we compress the image, the more that's going to get thrown away, the smaller the image, and the more likely we will see a change in quality of that image. So that's an important relationship. So let's take a look at that again. So what I'm talking about is that if we take the amount of compression and we pressed the wrong button there. And we increase the amount of compression, the file size is going to decrease. With the lossy file format, the image quality will also decrease. Again, this is for a lossy file format. In regards to the lossless file format, there is no change. And the reason for that is with a lossless file format, we're not throwing any of the data away, so the image quality is not going to change. the file size it'll get smaller, slightly smaller, but nonetheless smaller. So the relationship between compression and file size is inverse. As we increase one, the other one decreases. As we apply more compression in a lossy file format, we're throwing away more data. The image quality is going to go down. So there's this balance when we're using lossy file formats. How much compression do we apply? Well, the more we apply, we'll have a poorer image, but we have a smaller file size, which is very desirable because on a web page, for example, we want that file to be small so it loads very, very quickly. Or in other applications, we want it to load quickly. We don't want to take up a lot of space. But in doing so, our image suffers. Okay, well, maybe let's not apply so much compression. Now our image is nice, but our file size is bigger and it's going to take longer to load. So it's trying to find that happy medium in order to make that work. All right. Also relating to images, and this is to the bitmapped images, there is this concept of bit depth. As I mentioned with bitmapped images, each one of those pixels, each one of those little squares in that image, was a certain color when we zoomed in on that in Photoshop. Well, it needs to record that color of that pixel. Well, how many different colors can it represent? Well, that's going to be determined by the bit depth. It's also going to be affected by the number of channels. For example, in a grayscale image, a black and white image, there is only one channel. In color images, there are typically 3. You may hear them referred to as R, G, and B, and it depends on the color model as well. There are some cases where there'll be a 4th channel. If there is a 4th channel, that would be the alpha channel. And an alpha channel is used for transparency. And apologize, I'm going to run out of room there. Let me move that down. So alpha channel is for transparency. Some images can have portions of the image transparent. That is done through that 4th channel, that alpha channel. Not all file formats support that. There are some that do. In dealing with the bit depth, as the bit depth increases, the number of colors that can be represented also increases. For example, if I have a 1 bit, bits are either 1s or 0s. So with 1 bit, I could represent 2 colors. If it were a black and white image, a grayscale image, my 2 colors typically would be black and white. With some file formats, I can specify what those 2 colors would be. They could be any 2 colors. If I had, and I can have like 2 and 4 bits, 8 bits. If I had 8 bits, I can have 256 colors. So if we were dealing with a single channel, grayscale image, I could have 256 shades of gray going from white to black. Now with a color image, I would have 3 channels. As I mentioned, red, green, and blue. Each of those would have 8 bits. Each would then be able to do 256 different colors, and by combining those I can get into millions of different colors. So the bit depth is going to determine the number of colors that are available, but also as my bit depth increases, the number of color increases, my file size will also increase. So if I had a black and white image, and if I were using 1 bit, that would not take up as much space as the image that is using 8 bits and 256 shades of gray. If I had a photographic image that were color, everything else being the same, if that image were converted to grayscale, that image would be smaller in terms of file size. So there's this relationship. They're all proportional. So as one increases, the other increases. So as the bit depth increases, I get more colors. But the drawback is that I've got a larger file size. So that's bit depth. Let's deal with some of the specific file formats. One of the graphic file formats is the JPEG. The JPEG is a very good file format, primarily intended for photographic types of images. And those are sometimes referred to as continuous tone images. It can be lossless, and it can also be lossy, depending upon the exact variety of JPEG that's being used. There are different standards or different formats associated with JPEGs. So it can be made to be lossless, and it can be made to be lossy. And if it's lossy, you usually can pick how much compression is being applied. So the amount of compression is adjustable in almost all cases with the JPEG. So it is very good at compressing these photographic images, because most of the time it is applied in a lossy form. You will see that it greatly reduces the file size. Let me see if I can show you here in an example. So let me pull up. So here I have my original image. It has a particular size as it relates to the amount of data that's associated with it. Right now I have the settings set that this is a JPEG at the maximum, so my quality is set at 100%. Here is the version of that original. So here's the original. Here's the version based on my settings that I just mentioned and showed you. Here's the resulting not change, but this is the resulting file size. So you can see that it went from 14.4 meg to 4.23 meg. It's also giving me down here, based on a dial-up modem 56.6K, how long it would take for that to load. Let's change it to something like cable DSL. So if I left it that way, it could take 88 seconds for that to load. I can tweak my settings, and I'm going to now change the quality slider, and I'm going to do that. I'm not going to keep moving this back and forth so that you can see those changes, but what I'm going to be doing is changing this quality slider, and this quality slider corresponds to the amount of compression that's going to be applied. So I can make this more lossy. So I'm going to pull this back up so that you can see the resulting change in that file size. So right now it's set for 100, and I'm going to put it about 60, and you'll see now the file size is smaller. The reason why there's two windows here is because it allows you to compare the two. And being a video and being at 100% right now, you might not notice much change. JPEGs are pretty good at doing that. I'm going to take it down some more. I'm going to take it down to about 30. There's 30. You can see the file size is much smaller than it was originally. Now it's only going to take 17 seconds to load. Still looking pretty good. I'm going to take it down even more. Now it's going to be down right around 10. So that you can see some of those changes, I'm going to change my magnification. And again, not quite sure how it's going to come through on the video, but I see some pixelation in my original, but I certainly see more in this version. I'm going to see if I can exaggerate that just a little bit. And it becomes more muddy and blockish. You might be able to see it looks like there's bigger rectangles in this area. That's because of the compression. In here I can see some blockiness, some of the compression artifacts that are starting to occur. I'll move around a little bit more there. They're a little bit more visible in this area. So there's certainly a trade-off, but you'll notice the JPEG also does a very good job of compressing. So that's one of the file formats, the JPEG. Another file format for bitmapped images is the BMP, bitmapped. It is a lossless file format. It is primarily intended, any lossless file format is primarily intended for editing purposes. It's not generally used for distributing your final work because the file size is so much bigger. So if you are scanning something, you ideally would want to save that in a lossless file format so that you preserve all the data, so you have all the data in order to manipulate that image. There are other file formats, graphical file formats, that are lossless and that can also be used. Ideally, with a digital camera, you would also want to be saving your images either as a bitmap, if your camera were able to, as a JPEG with it set to being a lossless or nearly lossless file format, or a TIFF. A TIFF is another lossless file format. And the reason for that is if you decide after you've taken the picture and it's in a lossless format, you want to make it smaller, you can make it smaller. You can apply compression to it. You can go ahead and throw away that data that you don't want in order to make it smaller. But if you take that picture, if you scan that image and you save it immediately in a lossy file format, you've already thrown away data. You can never ever get that data back. So when you are creating, when you are scanning, when you are taking photos, ideally put them into a lossless file format, and bitmapped is one of those that's available. It's a little bit more common with scanned types of images. It works well for photographic types of images. It can also be used for some others, but typically you're going to see it for photographic. Another type of bitmapped file format is the GIF or GIF. I've heard people pronounce it both ways. It is a file format intended for, of course, bitmap file format for file images, but for those that have fewer colors and areas of the same color. And what I mean by fewer colors is those that are less than 256. So if you created something in a program, a bitmapped program like Paint, and you created circles and squares and text, and they were relatively all the same color, variations of color, not many colors, logo type things, a GIF would be very well designed for that. It will do a better, you could save it as a JPEG, but the GIF is going to be a better choice for that because of the content of that graphic image. So when you have areas of relatively large areas of relatively the same color, when you have fewer colors, the GIF is going to be a good way to go. It also supports transparency. So you have that option. Not all GIFs will have transparency, but it can. It also can support animation. So you may have heard of animated GIFs. Basically what's happening there is a series of still images, GIFs, that are played back in a sequence to give the impression of a movement or movie. And there's called animated GIFs. So they have a couple different options that are somewhat convenient in some cases. All right, let's look at another one. We have the ping. Still dealing with bitmap file formats. This one works very well for photographic types of images. It is a lossy file format. Where it is different from the JPEG is it supports transparency. The JPEG does not support transparency. So if you had some type of image, you wanted a photographic type image, you wanted some portion of it to be transparent. In other words, you want that alpha channel, you want that fourth channel. Can't do that in a JPEG, but you can do that in a ping. All right. Related to the JPEG is EXIF. And EXIF contains metadata. So we need to understand what metadata is. Metadata is data about data. For example, if you take a picture with your digital camera and you save it as a JPEG, it can save information about that picture. It might be about the aperture. It might be about the exposure of that particular picture or shot. It might be the time or the date the picture was taken. In some cases, some cameras, it records GPS coordinates, so you know where the picture was taken. The EXIF could be a separate file, but in many cases with the digital cameras, the EXIF data becomes a part of the JPEG. So if you were to open that JPEG in an application, that many applications will be able to read that EXIF or metadata information, telling you again aperture, exposure, time, date, where it was taken. And that can be very, very useful. All right. Another concept here, upsampling versus a downsampling. Upsampling is the idea of going from something of lower settings, lower quality settings, to higher quality settings. You should avoid upsampling, because here's why. Let me put upsampling here. With upsampling, the image quality is going to remain unchanged. But the file size is going to increase. So there's no benefit. You made things worse. The image looks the same, but it takes up more space. Let me give you an example. You have a JPEG, and that's in a lossy format, and you then save it in this bitmapped file format. You're going from a lossy to a lossless format. You're in some sense doing an upsample. Let me make another metaphor, another kind of example here, but not as it relates to graphic file formats. Let's say you have a piece of audio. It's very low quality audio. It would be comparable to the audio that would be played on an AM/FM radio. If you then go into an audio system and you say, I want this to be saved at CD quality audio, it's not going to sound any better. But the file size that corresponds to that new upsampled audio is bigger. So in a similar way, you didn't do anything to improve the quality of, in this case, audio. All you did is make the file size bigger. So avoid upsampling, because there is no benefit to doing it. However, in downsampling, we do want to do this, and we want to do it when it's appropriate. I mentioned that what we want to start with is a lossless, when possible, a lossless file. Do all of our editing on the lossless file. So lossless files are primarily for when we go to edit the file, when we are creating, when we are modifying our content. However, that's not the way we want to distribute it. We would not put a lossless file on a website. We would not put a lossless file into a PowerPoint. We would not put a lossless file into a final application. We would want to change it. So we would want to downsample it more than likely to some lossy form, and that's normally because that's how we want to distribute our final product. So in general, downsampling is okay. It's okay when we now need to distribute that product. We still keep our lossless file. We create a different version of it. So again, using that audio example, we might be in a recording studio and record something at very high quality settings, save everything in a lossless format, do all of our editing, but we're not going to distribute that to the public in that form. What is going to happen? It'll be saved as something like an MPEG-3. Why? MPEG-3 is like a JPEG of audio. It does a really good job of making the audio file smaller, throwing lots of things away, but ideally those things that we're not going to notice, those frequencies and tones that most people can't pick up. So same idea. We start with the lossless. When we are ready to distribute, we create a version that's lossy. All right. Just going through some notes here. Another file format commonly used is the TIFF. TIFFs are normally used in a lossless form. There are some ways to apply compression and apply it in a lossy kind of way, but almost always you're going to find it in a lossless form. They are commonly used in preserving bitmaps that are going to be put into printed documents. So it's not a file format for printed document. It's a file format for graphic type images that are going to be used in a printed document, like a brochure, like a magazine, like a book. So they are primarily for those graphic types of images in those documents. And the reason for that is when these brochures and magazines and books are printed, they need lots of information associated with that image so that the quality of that printed image is going to be the way they want it. It's going to be of reasonable quality. They don't want to put a JPEG into that printed document. So the TIFFs are commonly used for that. Some digital cameras will give you a choice of maybe saving your images as a JPEG, possibly saving it as a TIFF. If those are the only two choices, then the TIFF is going to be the lossless form. The JPEG will probably be set up as a lossy form, though the TIFF's going to take up more room because it is a lossless file format. Okay, let's move on to a little bit on the vector-based images file formats. Now this isn't going to be as extensive of a discussion as it was done with the bitmap. I've already discussed that vector file formats, vector images, are those that use draw instructions on how to draw the elements. So if we tell in a particular program that we have a line that starts at point A and B, if this is magnified, it takes and redraws that between those 2 points, so it's always a crisp line. If it's a circle, when that is magnified or reduced, the system redraws that circle based on instructions that are part of that file format. Same thing if it's a rectangle or whatever it may be, whatever shape. There are instructions that tell how to draw that shape, whatever the magnification is. A program that's commonly used to create vector types of images is Adobe Illustrator. And it has a .ai extension. Another product similar is CorelDRAW. It has a .cdr. Some of the vector programs, applications are considered to be 2D, like Illustrator, like CorelDRAW. Other programs can actually create 3D representations of objects. Autodesk's popular program, AutoCAD, can create images, and there are vector images, so you might see a DWG. Another one is IGES. So there are a variety of different file formats depending on the programs. And here's a good point. Illustrator, the .ai, that's the native file format. CorelDRAW, the .cdr, is its native file format. .dwg, AutoCAD's native file format. IGES is not a native format. It's one of those like JPEG. And many of these programs can save things as an IGES. Another one is an STL. Some of these can do that. An STL is a stereolithographic file. So if you had a 3D printer, and you created a 3D object in something like Autodesk's Inventor, you could save it as an STL because many of the printers require that. So the STL would not be a native file format. It's one of those non-native file formats. All right. So hopefully you understand here then the difference between these file formats, which ones are appropriate for which situations, how they differ in compression, how they differ based on application, how they differ based on the desired characteristics, the different kinds of controls and settings that we have. All right, very good. Thank you.